Good afternoon, sixth graders. It's Mrs. Hebert, and today we are going to be taking notes on lesson 9.2, which is all about prime factorization. And so these should be pages 47 and 48 in your table of contents. So go ahead and list this lesson in your table of contents, and we will be ready to move on. Okay, go ahead and set up your page. The top should be lesson 9.2, and the title is Prime Factorization. And then I forgot to put the numbers on this paper, so just go ahead and number your, divide your paper into 6 boxes and number each box. Okay, so in box number 1, we're just going to basically, this is really just review. This whole lesson really is review because we've talked about it before this year. So in box number 1, you're going to do the definition for factors. And factors are whole numbers that are multiplied to find a product. So for example, in the multiplication problem, 2 times 3 equals 6. 2 and 3 are factors because you multiply those to find the product, which is 6. Okay, in box number 2, I apologize that it's kind of blurry, but you don't have to write much in box number 2. And because really, again, it's just a review of finding factors. So if we need to find all the factors of a number, we basically just go through and find what 2 numbers can you multiply to get that number. And so we always start out with 1. And so you would, in this case, it would be 1 and 12. And then 12 is also divisible by 2, so 2 is a factor, so 2 times 6. And then 3, because 12 is divisible by 3, so 3 times 4 is a factor. When we start repeating, we know we're done. So if my next number were 4, I already have 4 listed on my list, so this is it for my factors. So there are basically 6 factors of 12. Okay, in box number 3, we're just going to write the definition for prime factorization. And prime factorization is the number written as a product of its prime factors. And we're going to, in the next box, talk about this more. But again, it's a number, but it's basically, instead of writing the number, you write it as a product of its prime factors. So you write it with its prime factors. Okay, in box number 4, we're going to talk about how to find prime factors, and again, we've already covered this in class, so this is really review. One way you can find prime factors, one popular way, is the tree method, and the other way is the ladder method. So I'm going to show you, just review again those 2 methods, and we're going to use 12 because it's easy. It's an easy one to review with. So with 12, we basically kind of make an arrow, and we come up with 2 factors that multiply together to give you the product of 12. So you can do any 2 numbers. I'm going to do 3 times 4, but you could do 2 times 6. And then when I get a prime factor, remember that's when a prime number is any number that only has itself and 1 that you can multiply together to get that number. So 3 only has 1 and 3. You can only multiply 1 times 3 to get 3. And so or at least whole numbers, and so that's already a prime number. So when it gets to prime, I'm going to circle it, and I'm done with that one. I don't have to worry about it until the end. But 4 is not prime, it's composite, and so I'm going to come up with 2 factors that would give me 4, and that would be 2 times 2, and remember that dot represents a multiplication sign. 2 is a prime number, so I already have my number factored out to its prime factors. And then I list those factors in order from smallest to largest. So 2 times 2 times 3. That is one way to list the prime factors of 12. But another way, and the way you'll more commonly see it from here on out, is you multiply you show 2 times 2 as 2 squared times 3. And again, we go in order from smallest to largest. And those are the prime factors for the tree method. With the ladder method, you are going to create an L shape and sometimes it's called the step or birthday cake method. And you're going to do the same thing. You're going to say, okay, what is 12 divisible by? Well, what is a factor of 12? 3 is a factor of 12 because you can say 12 divided by 3. So, and we want to pick out prime factors over here on the left side of our ladder. So I pull out 3 because it's prime. I could pull out 2, but I just happen to start with 3. And so 12 divided by 3 is 4. And then since 4 is not prime, I keep going, and I'm going to go down until I get to 1. So I have 4, and I need to know what is 4 divisible by. Well, it's divisible by 2, so 2 is a factor. So, and it's prime, so I pull out 2. And 4 divided by 2 is 2. So then I create another level. And 2 is divisible by another prime number, which is 2. And that gives me 1. When I get to 1, I'm done. I call it 1 and done. I don't need to count my 1 as a prime factor, remember? It will only be the other numbers not including 1. Remember that 1, a prime number is a natural number that's greater than 1. So it's not considered a prime number. Okay, so now I'm going to list those factors on the left. And again, I'm going to take them from smallest to largest as many times as they occur. So 2 times 2 times 3. And again, I can rewrite that as 2 squared times 3. So either way, I get the same answer. Okay, in box number 5, we're just going to practice the 2 kinds of methods to find the prime factorization for a larger number, which in this case is 132. Now, you may know other factors, but if you don't know other factors of 132, you know at least that it's divisible by 2 because it's an even number. So I'm going to start out with 2. So 2 times 66 gives me 132. 2 is already prime, so I'm going to circle it, and I'm not going to worry about it anymore until the end. Now I'm going to factor out 66 down to its prime numbers, and 66 is 2 times 33. Here's another prime number, so I'm circling it. I'm done with that one. Now I'm going to factor out 33, and that's 3 times 11. Now, 3 and 11 both happen to be prime, so I'm done because I have 132 factored out to all prime numbers. And so if I write those factors, it would be, my prime factorization would be 2 times 2 times 3 times 11. But you will most likely see it as 2 squared times 3 times 11 most of the time. And we're done there. You can do the same thing with the ladder method. Pull out the 2. 132 divided by 2 is 66. I can pull out 2 from 66, and that gives me 33. Then I can pull out 3, and 3 times 11 is 33. And now I am down to, I'm sorry, yeah, I could do it either way. I can say pull out 3 from there and get 3 times 11, and then 11 divided by 11 gives me 1. Or I could divide by 11 and get down to 3. But either way, once I get down to 1, 1 and done. So I take my prime factors, which are 2, 2, 3, and 11, and I write them out. And then I write it the way you'll normally see it. And I'm done. And you should have the same answer either way. Okay, for box number 6, we're going to write down a word problem, and then we're going to solve it. So the word problem is that Brandon has 32 stamps. He wants to display the stamps in rows with the same number of stamps in each row. How many different ways can he display the stamp? This kind of question is really a factoring question because they want to know if you're going to do, how many ways can you display it if you have, even rows, basically. So again, what I'm going to do is I'm going to factor out 32. And in this case, the easiest way is just to list my factors. So 1 and 32, 2 and 16, 2 times 16, 3 times nothing, so that won't work, but 4 times 8 will give me 32. There's nothing times 5. nothing times 6, and nothing times 7. That will give me 32. When I get to 8, I've already done that one, and so I am done. So basically, however many factors there are, that's how many ways I can do it usually, because I'll show you in a minute, but I have 1, 2, 3, 4, 5, 6. So there are 6 ways. And if I want to check that, I can list. Well, I can have one row of 32 or 32 rows of 1. I can have 2 rows of 16 or 16 rows of 2. I can have 4 rows of 8 or 8 rows of 4. And here are all 6 ways that I can do it. Basically, the different combinations of ways I can do it. And that is basically it. This is really all review, but we wanted to make sure to cover it again, just to make sure you have a good understanding of it as we move forward. And you're done. Have a good day. Oops, I almost forgot. This is what your paper looks like when you're finished. It looks similar to this. Sorry, I forgot that part. Now you're done.